I remember, those older days myself, right? That is really like I have this struggle that I feel like I can do better. I feel like I have an idea to contribute. But it just, for whatever reason, right, it took me forever to learn something, which I feel like it's very mechanical thing, but it just takes me forever to learn, right? And then now actually I see this hope, right, with AI, a lot of mechanical things that can actually now be done in a much more automated way, by AI, right? So then now truly, my daughter, many girls, many kids out there, right? Whatever, they are good at, their creativity, it'll be much easier, right, for them to contribute their creativity to whatever discipline they are passionate about.
You're listening to Ideas, a Microsoft research podcast that dives deep into the world of technology research and the profound questions behind the code. I'm Gretchen Huizinga. In this series, we'll explore the technologies that are shaping our future and the big ideas that propel them forward. Today, I'm talking to Shan Lu, a senior principal research manager at Microsoft Research and a computer science professor at the University of Chicago. Part of the systems research group, Shan and her colleagues are working to make our computer systems, and I quote, secure, scalable, fault-tolerant, manageable, fast, and efficient. That's no small order, so I'm excited to explore the big ideas behind Shan's influential research and find out more about her reputation as a bug bounty hunter. Shan Lu, welcome to Ideas.
Thank you.
So I like to start these episodes with what I've been calling the research origin story. And you have a unique, almost counterintuitive story about what got you started in the field of systems research. Would you share that story with our listeners?
Sure. I grew up fascinating that I would become a mathematician. I think I was good at math, and at some point, actually, until I think I entered college, I was still, thinking about, should I do math? Should I do computer science? For whatever reason, I think someone told me, doing computer science will help you. It's easier to get a job. And I reluctantly pick up computer science major. And then there was a few years in my college. I had a really difficult time for programming. And I also remember that there was I spent a lot of time learning one language. We started with Pascal. And I felt like I finally know what to do. And then there's yet another language, C, and another class, Java. And I remember the teacher would ask us to do a programming project. And there are times I just don't know how to get started. And I remember at that time in my class, I think there were, we only had 4 girls taking this class that requires programming in Java. And none of us have learned Java before. And when we ask our classmates, when we ask the boys, they just naturally know what to do. It was really, really humiliating, embarrassing. I had the feeling that I felt like I'm just not born to be a programmer. And then I came to a graduate school. I was thinking about, what kind of research direction I should do. And I was thinking that, maybe I should do theory research, complexity theory or something. After a lot of back and forth, I met my eventual advisor. She was a great, great mentor to me. And she told me that, hey, Shan, my group is doing research about finding bugs in software. And she said her group is doing system research. And she said a lot of my team members are all great programmers. And as a result, they are not really well motivated by finding bugs in software.
Interesting.
And then she said, you are really motivated, right, by, getting help to developers, to help developers finding bugs in your software. So maybe that's the research project for you. So that's how I get started.
Well, let's go a little bit further on this mentor and mentors in general. As Dr. Seuss might say, every what has a who. So by that, I mean an inspirational person or people behind every successful researcher's career. And most often they're kind of big names and meaningful relationships, but you have another unique story on who has influenced you in your career. So why don't you tell us about the spectrum of people who've been influential in your life and your career?
Yeah, I mean, I think I mentioned my advisor, and she's just so supportive. And I remember when I started doing research, I just felt like I seems to be so far behind everyone else. You know, I felt like, how come everybody else knows how to ask, insightful questions, and they know how to program really fast, bug-free. And my advisor really encouraged me, saying, there are background knowledge that you can pick up. You just need to be patient. But then there are also how to do research, how to think about things, problem solving. And she encouraged me, saying, Shan, you're good at that. Well,
Interesting.
I don't know how she found out, and anyway, so she was super, super helpful.
Okay, so go a little further on this, because I know you have others that have influenced you as well.
Yes. And I think, so to be honest, I'm a very emotional, sensitive person. I would just, move the timeline to be kind of more recent. So I joined Microsoft Research as manager. And there's something called Connect that people write down twice every year talking about what they've been doing. So I was just checking, my members in my team to see what they have been doing over the years, just to just get myself familiar with them. And I remember read several of them. I felt like I almost have tears in my eyes. Like I realized, wow, and just to give example, for Chris Hobbliso, I read his Connect, and I saw that he's working on something called program verification. It's a very, very difficult problem. And from outsider, I've read many of his papers, but when I read, his own writing, and I realized, wow, it's almost 2 decades, right? He just keep doing these very difficult things, and I read his words about, how his old approach has problem, how he's thinking about how to address that problem. Oh, I have an idea, right? And then spend multiple years to implement that idea and get an improvement, find a new problem, and then just find new solutions. And I really feel like, wow, I'm really, really, I feel like this kind of there's a hero-ish story behind this, this kind of goal, and you're willing to spend many years to keep tackling this challenging problem. And I just feel like, wow, I'm so honored, to be in the same group with a group of fighters, determined to tackle difficult research problems.
Yeah, and I think when you talk about it, it's like this is a person that was working for you, a direct report. And often we think about our heroes as being the ones who mentored us, who taught us, who managed us. But yours is kind of 360. It's like
True.
Your heroes above, beside, and below.
Right. And I would just say that I have many other, direct reports in my group. And I have, for example, say a couple of other my colleagues, my direct reports, Dan Potts and Jacob Nelson. And again, this is something like their story really inspired me. Like they were, again, spent 5 or 6 years on something, and it looks like, it's close to the success of tech transfer. And then something out of their control happened. This happened because Intel decided to stop manufacturing a chip that their research relied on. And it's kind of like end of the world to them. And then they did not give up. And then, 1 year later, they found a solution, together with their product team collaborators.
Wow.
And I just feel like, wow, I feel like I'm inspired every day. Like I'm so happy to be work together with all these great people, great researchers in my team.
Yeah. Wow. So much of your work centers on this idea of concurrent systems. And I want you to talk about some specific examples of this work next, but I think it warrants a little explication up front for those people in the audience who don't spend all their time working on concurrent systems themselves. So give us a short 101 on concurrent systems and explain why the work you do matters to both the people who make it and the people who use it.
Sure. Yeah. So I think a lot of people may not realize. So actually, the software we're using every day, almost every software we use these days are concurrent. So the meaning of concurrent is that you have multiple threads of execution going on at the same time in parallel. And then when we go to a web browser, right? So it's not just one rendering that is going on. There are actually multiple concurrent rendering that is going on. So the problem of writing for software developers to develop this type of concurrent system, a challenge is the timing. So because you have multiple concurrent things going on, it's very difficult to manage and reason about, what may happen first, what may happen second. And also it's like there's an inherent non-determinism in it. What happened first this time may happen second next time. So as a result, a lot of bugs are introduced by this. And it was a very challenging problem because I would say about 20 years ago, there was a shift. Like in the old days, actually most of our software is written in a sequential way instead of concurrent way. So, a lot of developers also has a difficult time to shift their mindset from the sequential way of reasoning to this concurrent way of reasoning.
Right. Well, and I think from a user's perspective, all you experience is what I like to call the spinning beach ball of doom. It's like, I've asked something and it doesn't want to give. And this is like behind the scenes from a reasoning perspective of how do we keep that from happening to our users? How do we identify the bugs, which we'll get to in a second. Thanks for that. Your research now revolves around what I would call the big idea of learning from mistakes. And in fact, it all seems to have started with a paper that you published way back in 2008 called Learning from Mistakes, a comprehensive study on real-world concurrency bug characteristics. And you say this strongly influenced your research style and approach. And by the way, I'll note that this paper received the most influential paper award in 2022 from ASPLOS, which is the Architectural Support for Programming Languages and Operating Systems. Huge mouthful. And it also has more than 1,000 citations. So I dare say it's influenced other researchers' approach to research as well. Talk about the big idea behind this paper and exactly how it informed your research style and approach today.
Yeah, so I think it's like, again, went back to the days that I, my PhD days, I started working with my advisor, YY. So at that time, there had been a lot of people working on bug finding. But then now when I think about it, people just magically say, hey, I want to look at this type of bug. Just magically, I want to look at that type of bug. and then my advisor at that time suggested me saying, hey, maybe, actually take a look, right? At that time, as I mentioned, software was kind of shifting from sequential software to concurrent software. And my advisor was saying, hey, just take a look at those real systems bug database and see what type of concurrency bugs are actually there, instead of just randomly say, oh, I want to work on this type of bug.
Oh, yeah.
And then also, of course, it's not just look at it. It's not just like you read a novel or something, right? And again, my advisor said, hey, Shan, right, you have a connection, natural connection, with bugs and the developers who makes them. So she said, try to think about the patterns behind them, right? Try to think about whether you can generalize some characteristics and use that to guide people's research in this domain. And at that time, we were actually thinking, we don't know whether, we can actually write a paper about it because traditionally you publish a paper, just say, I have a new tool, right, which can do this and that. At that time, in system conferences, people rarely have, just say, here's a study, right? But we studied that. And indeed, I had this thought that, hey, why I make a lot of mistakes. And when I study a lot of bugs, the more and more I feel like, there's a reason behind it, right? It's like I'm not the only dumb person in the world, right? There's a reason that, there's some there's some part of this language is difficult to use, right? And there's certain type of concurrent reasoning. It's just not natural to many people, right? So because of that, there are patterns behind these bugs. And so at that time, we were surprised that the paper was actually accepted. And because I'm just happy with the learning I get. But after this paper was accepted, in the next, I would say, many years, there were more and more people realize, hey, before we actually, do bug finding things, let's first do a study, right, to understand. And then this paper was, I was very happy. It was cited many, many times.
Yeah, and then gets the most influential paper many years later.
Many years later, yes.
I feel like there's a lot of things going through my head right now. One of which is what AI is a pattern detector, and you were doing that before AI even came on the scene, which goes to show you that humans are pretty good at pattern detection. Also, we might not do it as fast as an AI. But so this idea of learning from mistakes is a broad theme. Another theme that I see coming through your papers and your work is persistence. And you mentioned this about your team, right? I was like, these people are people who don't give up. So we covered this idea in an abstracts podcast recently, talking about a paper which really brings this to light. If at first you don't succeed, try again. That's the name of the paper. And we didn't have time to discuss it in depth at the time because the abstract show is so quick. But we do now. So I'd like you to expand a little bit on this big idea of persistence and how large language models are not only changing the way programming and verification happens, but also providing insights into detecting retry bugs.
Yes. So I guess maybe I will, since you mentioned this persistence, after that learning from mistakes paper, so that was in 2008, and in the next 10 years, a little bit more than 10 years, in terms of persistence, right?
Yeah.
So we have continued, me and my students, my collaborators, we have continued to working on, finding concurrency bugs.
Yeah.
Which is related to why I'm here at Microsoft Research. And we keep doing it. And then I felt like a high point was that I had a collaboration with my now colleagues here, Madan Musawasi and Shuman Ness. So we built a tool to detect concurrency bugs. And after more than 15 years of effort on this, we were able to find more than 1,000 concurrency bugs. It was built in a tool called Torch that was deployed in the company.
Yeah.
And it won the Best Paper Award at the top system conference, SOSP. And it was actually a bittersweet moment. This paper seems to, put an end to our research. And also some of the findings from that paper is that we used to do very sophisticated program analysis to reason about the timing. And in that paper, we realized actually sometimes if you're a little bit fuzzy, don't aim to do perfect analysis. The resulting tool is actually more effective. So after that paper, Madan, Shuman, and me, we kind of, shifted our focus to looking at other types of bugs. And at the same time, the three of us realized the traditional, very precise program analysis may not be needed for some of the bug finding. And so then for this paper, this retry bugs, after we shifted our focus away from concurrency bugs, we realized, there are many other types of important bugs, such as in this case, like retry, right? When your software goes wrong, right? Another thing we learned is that it looks like you can never eliminate all bugs. So something will go wrong. And and then so that's why you need something like retry, right? So if something goes wrong, at least you won't give up immediately. The software will retry. And another thing that started from this earlier effort is we started using large language model because we realized, traditional program analysis sometimes can give you very strong guarantee. But in some other cases, like in this retry case, some kind of fuzzy analysis, not so precise, offered by large language models, sometimes even more beneficial. Yeah, so that's kind of, the story behind this paper.
So, Shan, we're hearing a lot about how large language models are writing code nowadays. In fact, NVIDIA's CEO says, mamas, don't let your babies grow up to be coders because AI is going to do that. I don't know if he's right, but one of the projects you're most excited about right now is called Verus.
Mm-hmm.
And your colleague Jay Lorch recently said that he sees a lot of synergy between AI and verification, where each discipline brings something to the other. And Rafa Hosen has referred to this as co-innovation or bidirectional enrichment. I don't know if that's exactly what is going on here, but it seems like it is. Tell us more about this project, Verus, and how AI and software verification are helping each other out.
Yes. I'm very excited about this project now. So first of all, starting from Verus. So Verus is a tool that helps you verify the correctness of Rust code. So this is it's a relatively new tool, but it's creating a lot of excitement in the research community, and it's created by my colleague Chris Hoblisel and his collaborators outside Microsoft Research.
Interesting.
And as I mentioned, right, this is part that really inspired me. So traditionally, to verify your program is correct, it requires a lot of expertise. You actually have to write your proof typically in a special language. And, and so a lot of people, including me, right, who are so eager to get rid of bugs in my software, because there are people told me saying just to learn that language. So they were referring to a language called Cog. Just to learn that language, they said it takes 1 or 2 years. And then once you learn that language, right, then you have to learn about how to write proof in that special language. So people, particularly in the bug finding community, people know that, in theory, you can verify it. But in reality, people don't do that. Okay, so now going back to this Verus tool, why it's exciting. So it actually allows people to write proof in Rust. So Rust is a increasingly popular language. And there are more and more people picking up Rust. It's the first time, right? I heard about, you can, write proof in a popular language. And also another thing is, in the past, you cannot verify a implementation directly. You can only verify something written in a special language. And the proof is proving something that is in a special language. And then finally, that special language is maybe then transformed into an implementation. So there's just too many special languages there.
A lot of layers.
A lot of layers. So now this Verus tool allow you to write proof in Rust to prove an implementation that is in Rust. So it's very direct. I just feel like I'm just not good at learning a new language.
Interesting.
So when I came here, and learned about this Verus tool, by Chris and his collaborators, I feel like, looks like maybe I can give it a try. And surprisingly, I realized, wow, I can actually write proofs using this Verus tool.
Right.
And then, of course, I was told if you really want to write proof for large system, it still takes a lot of effort.
Yeah.
And then this idea came to me that, hey, maybe, these days, like large language model can write code, then why not let large language model write proof, right? And of course, other people actually has this idea as well, but there's a doubt that, can large language model really write proof, right? And also people have this feeling that, large language model seems not very disciplined, by nature. But that's what intrigued me, right? And also, I used to be a doubter for, say, GitHub CoPilot. Used to. And so because I feel like, yes, it can generate a lot of code, but who knows
whether it's right.
Whether it's right.
Yeah.
Right. So I feel like, wow, this could be a game changer, right?
Yeah.
Like if AI can write not only code, but also proof. Yeah, so that's what I've been doing.
Yeah.
I've been working on this for 1 year, and then I gradually get more collaborators, both people in Microsoft Research Asia, and expertise here like Chris and Jay Lodge. They all help me a lot. So we actually have made a lot of progress. Like now it's like we've tried, like for example, for some small programs benchmarks, and we see that actually large language model can correctly prove the majority of the benchmarks that we threw to it. Yeah, it's very, very exciting.
Well, and we're going to talk a little bit more about some of those doubts and some of those interesting concerns in a bit. I do want you to address what I think Jay was getting at, which is that somehow the two help each other. The verification improves the AI improves the verification.
Yes.
How?
Yes. My feeling is that a lot of people, if they're concerned with using AI, is because they feel like there's no guarantee for the content generated by AI, right? And then we also all heard about, hallucination.
Yeah.
And I tried myself. Like, I remember at some point, if I ask AI, say, which is bigger? Is it 3 times 3 or 8? And then AI would tell me 8 is bigger. And
what?
So I feel like verification can really help AI
Get better.
because now you can give, kind of add, mathematical rigorous into whatever that is generated by AI, right? And I would say it help AI. It will also help people who use AI, right? So that they know what can be trusted,
right.
what is guaranteed by this content generated by AI.
Yeah.
And now, of course, AI can help verification because, verification, it's hard. There a lot of mathematical reasoning behind it. And so now with AI, it will enable verification to be picked up by more and more developers so that we can get higher quality software.
Yeah, and we'll get to that too about what I would call the democratization of things. But before that, I want to again say an observation that I had based on your work and my conversations with you is that you've basically dedicated your career to hunting bugs.
Yes.
And maybe that's partly due to a personal story about how a tiny mistake became a bug that haunted you for years. Tell us the story and explain why and how it launched a lifelong quest to understand, detect, and expose bugs of all kinds.
Yes. So before I came here, I already had multiple times, interacting with Microsoft Research. So I was a summer intern at Microsoft Research Redmond almost 20 years ago. I think it was in the summer of 2005. And I remember I came here, full of ambition. And I thought, okay, I will implement some smart algorithm. I will deliver some useful tools. So at that time, I just finished 2 years of my PhD. So I kind of just started my research on bug finding and so on. And I remember I came here and I was told that I need to program in C#. I just naturally had a fear of learning a new language. But anyway, I remember I thought, the task I was assigned was very straightforward. And I think I went ahead of myself. I was thinking, I want to quickly finish this. And I want to do something more novel, that can be more creative. But then this simple task I was assigned, I ended up spending the whole summer on it. So the tool that I wrote was supposed to process very huge logs. And then the problem is my software is like, you run it initially, it's like, I can only run it for 10 minutes. So because my software uses so much memory, and then it will crash. And then I spent a lot of time, I was thinking, my software is just using too much memory. Let me optimize it, right? And then so I try to make sure it uses memory in a very efficient way. But then as a result, instead of crash every 10 minutes, it will just crash after 1 hour. And I know there's a bug at that time. So there's a type of bug called memory leak. I know there's a bug in my code. And I spent a lot of time, and there's also an engineer helping me checking my code. We spent a lot of time. We were just not able to find that bug. And at the end, the solution is I just sitting in front of my computer, waiting for my program to crash and restart. And at that time, because there was very little remote working option, so in order to finish processing all those logs, It's like, after dinner,
I
everyone.
had to stay all night.
I have to stay all night. And all my intern friends, they were saying, well, Shan, you work really hard.
Yeah.
And I'm just feel like, what I'm doing, just sitting in front of my computer, waiting for my program to crash so that I can restart it. And near the end of my internship, I finally find the bug. It turns out that I missed a pair of brackets in one line of code.
That's it.
That's it.
Oh my goodness.
And then turns out, because I was used to C, and in C, when you want to free, which means deallocate an array, you just say free array. And if I remember correctly, in this language, C#, you have to say free this array name and you put a bracket behind it. Otherwise, it will only free the first element. And it was a nightmare. And I also felt like the most frustrating thing is, it's a clever bug, right?
Sure.
Then you feel like at least I'm defeated by something complicated, something smart. And then it's like, also all this ambition I had about, doing creative work, right, with all these smart researchers in MSR. I feel like I ended up achieving very little in my summer internship.
But maybe the humility of making a stupid mistake is the kind of thing that somebody who's good at hunting bugs, it's like missing an error in the headline of an article because the print is so big that you're looking for the little things in the. I know that's a journalist's problem. I actually love that story, and it kind of presents a big picture of you, Shan, as a person who has a realistic self-awareness of and humility, which I think is rare at times in the software world. So thanks for sharing that. So moving on, when we talked before, you mentioned the large variety of programming languages and how that can be a barrier to entry, or at least a big hurdle to overcome in software programming and verification. But you also talked about, as we just mentioned, how LLMs have been a democratizing force in this field. So going back to when you first started and what you see now with the advent of tools like GitHub CoPilot, what's changed?
Oh, so much has changed. Well, I don't even know how to start. Like I used to really scared about programming. When I tell this story, a lot of people say, no, that I don't believe you. And I feel like it's a trauma. I almost feel like it's like, the college day me, right, who was scared of starting any programming project. Somehow I felt humiliated when asking those I feel like stupid questions to my classmates. It almost changed my personality. It's like for a long time, whenever someone introduced me a new software tool, my first reaction is, I probably will not be able to successfully even install it. Like whenever, there's a new language, my first reaction is, no, I'm not good at it. And then, like, for example, this GitHub CoPilot thing, actually, I did not try it until I joined Microsoft. And then I haven't programmed for a long time. And then I started collaborating with people in Microsoft Research Asia, and he write program in Python, right? And I have never written a single line of Python code before. And also this Varus tool, it helps you to verify code in Rust. But I have never learned Rust before. So I thought, okay, maybe let me just try GitHub CoPilot. And wow, it's like I realized, wow, like
I can do this.
I can do this. And then of course, sometimes I feel like my colleague may sometimes be surprised because on one hand, it looks like I'm able to just finish, like, write a Rust function. But on some other days, I ask very basic questions. And I have those questions because, the GitHub CoPilot just helped me finish.
Right.
I just starting something to start it, and then it just helped me finish. And I wish when I started my college, if at that time there was GitHub CoPilot, I feel like, my mindset towards programming and towards computer science might be different. So it does make me feel very positive, I about, what future we have, with AI, with computer science.
Okay. Usually I ask researchers at this time what could possibly go wrong if you got everything right. And I was thinking about this question in a different way until just this minute. I want to ask you, what do you think that it means to have a tool that can do things for you that you don't have to struggle with? And maybe is there anything good about the struggle? Because you're framing it as it sapped your confidence.
Yes.
And at the same time, I see a woman who emerged stronger because of the struggle with an amazing career, a huge list of publications, influential papers, citations, leadership role. So in light of that,
Right.
what do you see as the tension between struggling to learn a new language versus having this tool that can just do it, that makes you look amazing? And maybe the truth of it is you don't know.
Yeah, that's a very good point. I guess you need some kind of balance. And on one hand, yes, I feel like, again, right, this goes back to my internship. I left with the frustration that I felt like I have so much creativity to contribute, and yet I could not because of this language barrier. I feel positive in the sense that just from GitHub CoPilot, right, how it has enabled me to just bravely try something new. I feel like this goes beyond just computer science, right? I can imagine it will help people to truly unleash their creativity, not being bothered by some challenges in learning the tool. But on the other hand, you made a very good point. My advisor told me she feels like, I write code slowly, but I tend to make fewer mistakes. And the difficulty of learning, right, and all these nightmares I had definitely made me more cautious. I pay more respect to the task that is given to me. So there is definitely the other side of AI, right? Which is you feel like everything is easy, and maybe you did not have the experience of those bugs, right, that a software can bring to you, and you have over-reliance, right, on this tool. So hopefully, some of the things we are doing now, right, like, for example, say verification, right, like bring this mathematical rigor to AI. Hopefully that can help.
Yeah. Even as you unpack the nuances there, it strikes me that both are good. Both having the struggle and learning languages and understanding the core of it, and the idea that in natural language you could just say, here's what I want to happen, and the AI does the code, the verification, etc. That said, do we trust it? And this was where I was going with the first what could possibly go wrong question.
Yeah.
How do we know that it is really as clever as it appears to be?
Yeah, I think I would just use the research part we are working on now, right? Like, I think on one hand, I can use AI to generate proof, right? To prove the code generated by AI is correct. But having said that, even if we're wildly successful, in this thing, human beings' expertise still needed. Because just take this as an example. What do you mean by correct, right?
Sure.
And so someone first has to define what correctness means.
Yeah.
And then so far, the experience shows that you can't just define it using natural language, because our natural language is inherently imprecise.
Sure.
So you still need to translate it to a formal specification in a programming language. It could be in a popular language like in Rust, right, which is what Varus is aiming at. And then we are, like, for example, some of the research we do, it shows that, yes, I can also use AI to do this translation from natural language to specification. But again, then who to verify that, right? So at the end of the day, I think there still do need to have human in the loop. But what we can do is to lower the burden and make the interface not so complicated, right? So that it will be easy for human being to check what AI has been doing.
Yeah. Everything we're talking about just reinforces this idea that we're living in a time where the advances in computer science that seemed unrealistic or impossible, unattainable, even a few years ago, are now so common that we take it for granted. And they don't even seem outrageous, but they are. So I'm interested to know what, if anything, you would classify now as blue sky research in your field. Maybe something in systems research today that looks like a moonshot. You've actually anchored this in the fact that you kind of have, blinders on for the work you're doing, head down in the work you're doing. But even as you peek up from the work that might be outrageous, is there anything else? I just like to get this out there that, what's going on 10 years down the line?
Sometimes I feel like I'm just now so much into my own work. But, occasionally, like say when I had a chat with my daughter and I explained to her, I'm working on, not only have AI to generate code, but also have AI to prove, right, the code is correct. And she would feel, wow, that sounds amazing. So I don't know whether that is, a moonshot thing, but that's a thing that I'm super excited about the potential. And then there also have, my colleagues, we spend a lot of time build system, and it's not just about correctness, right? Like the verification thing I'm doing now is related to automatically verify it's correct. But also you need to do a lot of performance tuning, right? Just so that your system can react fast, right? It can have good utilization of computer resource. And my colleagues are also working on using AI, right, to automatically do performance tuning. And I know what they are doing, so I don't particularly feel that's a moonshot, but I guess...
I feel like because you are so immersed that you just don't see how much we think.
Yeah, and
it's amazing. Well, I'm just delighted to talk to you today, Shan. As we close, and you've sort of just done a little vision casting, but let's take your daughter, my daughter, all of our daughters.
Yes.
How does what we believe about the future in terms of these things that we could accomplish influence the work we do today as sort of a vision casting for the next Shan Lu who's struggling in undergrad, grad school?
Yes. Oh, thank you for asking that question. Yeah, I have to say, I think we're in a very interesting time, right, with all this AI thing.
Isn't that a curse in China? That may you live in interesting times?
And I think there were times, actually, before I myself fully embraced AI. I had my daughter in mind. I was worried when she grows up, what would happen? There will be no job for her because everything will be done by AI.
Oh, interesting.
But then now that I have, kind of fully embraced AI myself, actually, I see this more and more positive. Like you said, I remember, those older days myself, right, that is really like I have this struggle that I feel like I can do better. I feel like I have an idea to contribute. But it just, for whatever reason, right, it took me forever to learn something, which I feel like it's very mechanical thing, but it just takes me forever to learn, right? And then now actually I see this hope, right, with AI, a lot of mechanical things that can actually now be done in a much more automated way by AI, right? So then now truly, my daughter, many girls, many kids out there, right? Whatever, they are good at, their creativity, it'll be much easier, right? For them to contribute their creativity to whatever discipline they are passionate about. Hopefully, they don't have to, go through what I went through, right? To finally be able to contribute. But then, of course, at the same time, I do feel this responsibility of me, my colleague, MSR. We have the capability and also the responsibility, right, of building AI tools in a responsible way so that it will be used in a positive way by the next generation.
Yeah. Shan Lu, thank you so much for coming on the show today. It's been absolutely delightful, instructive, informative, wonderful.
Thank you. My pleasure.